Hey, it's Mr. N again, and we're going to go over some more Rolle's theorem and MVT with these practice problems. So, in the first one it says, determine if the mean value theorem and or Rolle's theorem applies to the function on the given interval. If either applies, then find the value of C or values of C that are guaranteed by the theorem. So, for Rolle's theorem, we've got a couple things that are going on. First, we need to know if it is continuous on my closed interval. Second, I need to know if it's differentiable on the open interval. And then third, I need to find out if f of a equals f of b. So we have that level playing field. If so, then I can find the c. For MVT, I need part 1 and part 2 of Rolle's, but then part 3 is different because now I'm looking to see if the secant equals the tangent line. And in this case, we'll have f prime of c, which is our tangent line, equaling f of b minus f of a all over b minus a. Okay, on this first one, we're given f of x equals 3x squared plus 2x plus 1 on the closed interval from -1 to 1. So the first thing we need to do is determine if this is continuous on my interval from -1 to 1. So yes, it is continuous. I can find all values where the function, I won't have to pick up my pencil if I trace it. Step 2, is this differentiable on, is the derivative differentiable on the open interval? So let's take the derivative, and then we end up with 6x plus 2 on the open interval from -1 to 1. Is this differentiable? Yes. Again, it's a polynomial, so it will be differentiable there. So now step 3, I need to determine if f of a equals f of b. So in this case, I'm given f of -1, and I plug -1 in, and I'll get 3 times -1 squared, which is 1, plus 2 times -1 plus 1, which will give me a value of 2. When I put in f of 1, I get 3 times 1 plus 2 times 1 plus 1, which is a value of 6. No, these are not the same, so Rolle's theorem in this case does not hold. So now I can move on to see if MVT, what happens with MVT. So here I'm going to take the derivative at c, which will give me 6c right here, plus right here, 6c plus the 2. So 6c plus 2 equaling f of, I'm looking up here, b minus f of a over b minus a. In this case, f of b is 6 minus 2 over 1 minus -1. So I'll get 6c plus 2 equaling 4 over 2, which is 2. So 6c equals 0, c equals 0. So I get the value of c. Now here's the important part. You need to check if this is in the interval. Is c in that interval? Yes, it is. So I found my value for MVT that works. All right, now moving on to number 2. In number 2, we have the function f of x equals a cosine of x. In this case, let's go ahead and see if Rolle's theorem holds. Step 1, is it continuous on this interval? Yes, it is. The cosine function is continuous. Secondly, let's take the derivative. F prime of x is going to give me negative sine x, and now I'm looking at the open interval from 0 to pi. Is it differentiable on this open interval? Yes, it is. So now step 3, I can go ahead and find f of a and compare it to f of b. F of a is going to be it's going to be cosine of 0, which comes out to be 1. F of b is going to be the cosine of pi, which is also 1. Those are the same values, so Rolle's theorem holds. And now I can find my c for this. Since it holds, I'll say f prime of c. In Rolle's theorem, we want it to be 0. So this becomes negative sine of c. And I'll get the values of c to be 0 and pi. Okay, now I'm going to go ahead and move on to MVT. For MVT, we've got parts 1 and 2 already set for us. So now I can find that f prime of c. So in this case, it's negative sine c equaling f of b, 1 minus 1, and then pi minus 0 over b minus a. In this case, I'll get negative sign c equals 0 again, so I get the same values. C equals 0 and pi for MVT. Again, those are in my closed interval, so they work and they check out. Okay, we're going to go ahead and move on to number 3. Let's shift this whole thing up, and let's look at what number 3 says. On number 3, it says f of x is a differentiable function and has the given values in the table below. So here are my values of x, my corresponding values for f of x. So before we move on, let's take a look at what these points tell me as far as graphically. So I'm just going to do a quick rough sketch, and it doesn't have to be perfect. Over here at 2, I've got a value of 32, so we'll put that way up there. At 5, I've got a value of 20. We'll put that right there. At 9, I have a value of 15. We'll just roughly put that in here. At 10, I'm back up to 20. And at 14, I'm up to 31, so right below that one right there. And then at 18, again, this is not a good graph, no scales. I'm just trying to get a visual of what's happening. I'm up at 44. So I'm up back over here. Now, here's what happens. Since this is differentiable, this is a key word right here in this problem, that it's differentiable. Since it's differentiable, automatically I know that it's continuous. Again, differentiability means it will be continuous. But if I said it's continuous, that doesn't necessarily mean it's differentiable, because we can have a kink in the graph, which is what we've talked about. But the key to this is that it is continuous, meaning all these points will be connected. Now, I don't know what happens in between these points, and that's a key part to this problem. This could go up between 2 and 5. It could skyrocket up, then come back down. It could come way back down here, then come back up. I don't know. But I do know is that when I do connect these points, I will never pick up my pencil because it is continuous. So, let's take a look at what part A says. In part A, it says, must there exist a value x equals c in the closed interval from 10 to 18 such that f prime of c equals 0? Since it says f prime of c equals 0, I'm going to think of Rolle's theorem. And in this case, I need to see if f of a at some point and f of b are the same. And any point, and now I'm looking in the interval that they specify from 10 to 18. So on the graph, it would be right in here. Well, take a look at this. Do I know that it's going to flatten out here? I don't have any values in between any of these points. It could come down. It could level out here. It could go up, then come back down to 20, then go back up. I don't know this. So I can't for sure find a value or assume a value where they are equal. So for this question, we will say no, no because of Rolle's theorem. So no because of Rolle's theorem, and we cannot assume a value. So no known values of, we'll say C1 and C2, such in the interval from 10 to 18, such that f of C1 equals f of C2. So I can't assume that, and we're not going to assume that because it could happen, but we don't know if it's going to or not. So the answer is no. Okay, moving on to part B. Must there exist a value x equals c in 2 to 10 such that f prime of c equals 0? Again, we're looking at Rolle's here. So let's think about this. This one, it says from 2 to 10. So I'm looking from 2 to 10 right in here. Oh, something I notice. Look at that. From 2 to 10. I notice that those have the same value for the f of x. Graphically, from 2 to 10, if I'm connecting this from 2 to 10 over here, notice that these two have the same height. So yes, there will be a value in there, since these two have the same height, according to Rolle, that f prime of c will be 0. So for this one, we will say Rolle's theorem holds because And let's find what those two values are. It happens to be at f of 5 equals 20, and f of 10 equals 20. So f of a, we have a spot where f of a equals f of b on my interval on 2 to 10. So there is a c such that f prime of c equals 0. Okay, moving on to part C. Let's slide this up a little bit more. I'll keep it so that at least we can see the table and the grid there. All right, on this one says, must there exist a value x equals c on 2 to 9 such that the derivative is equal to -1. Since I'm not looking for it to equal 0, let's go ahead and work with MVT now. So on this one, we're looking for it to be MVT because I'm trying to find this slope where the secant will be this tangent slope. So since I'm using MVT, let's go ahead and find, we want f prime of c to be this -1. And again, we're looking at the secant from 2 to 9. So in this case, I need f of 9 minus f of 2 over 9 minus 2 to be equal to this f prime of c value. Well, let's work this out. I end up with 15 minus 32 over 9 minus 2, which gives me -17 over 7. So when I'm looking at this from 2 to 9, from 2 to 9, right here, from 2 to 9, I cannot assume that anywhere in there I'll get a slope equal to -1. So this is approximately, if you work this out, -2.43. So I can't assume that it'll go back to a -1 value based on what I'm given with my known values. So the answer to this is no, there are no known values of c where f prime of c equals -1. So basically, I needed to get these two equal to that, and then I would know that, yes, there is a value there that would be that for this particular problem. All right, moving on to part D. Must there exist a value x equals c in 10 to 18 such that f prime of c equals 3? So now I need the tangent to be 3 and the secant to be 3. So let's take a look, and we are looking at from 10 to 18. 10 to 18, right in there. So I need to see if this secant connecting these two, if I could find a tangent that will be equivalent to that. Well, let's go ahead and use MVT again, since I have a slope given to me. So we need to find this f prime of c if there's a spot where it will equal 3. So I need f of 18 minus f of 10 all over the 18 minus 10. And in this case, f of 18, I look at my table and I get a value of 44. F of 10 gives me a value of 20 over 8. So this is 24 over 8. And look at that, I get a slope of 3, which is exactly what I'm looking for. So the answer to this, let's slide this up a bit. The answer to this is yes. MVT shows that there must be a value for C such that f prime of c equals 3. Again, what I'm looking for here is I'm looking for the secant to be equal to the tangent, and it is.